Hi, I'm Abby Fuller. I am a principal security engineer here at AWS, and I work on EC2 Nitro. So this session is Compute 301, and it is powering next-gen Amazon EC2, so a deep dive on our Nitro system. So first off, before we start, you may have noticed that reInvent and everything else is a little bit different this year. So if you have questions, you can tweet me or email me, and I'll help you if I can. And if I can't, I can help direct you to the right person. So my Twitter handle is @AbbyFuller, and my email address is abbyfull@amazon.com. And those will be at the end of the presentation as well. So if you didn't catch them now, you can catch them at the end, but totally happy to field any questions or just chat about AWS. So first off, let's talk a little bit about what Nitro is. So Nitro is the platform that powers all of our next generation Amazon EC2 instances. And traditional hypervisors do things like protect the BIOS and virtualize things like CPU. With Nitro, we broke those all apart, and we'll talk about that in a second. So we've been working on Nitro since 2013. We launched it in November 2017. Totally purpose-built from hardware to software, and it is a custom hypervisor developed solely for AWS. So every new instance launch we make uses Nitro, and I think that in 2018, we had 3 times the instance launches powered by Nitro than we had the previous year. So part of why we've built Nitro, right, is to be able to innovate more quickly on behalf of our customers. So it lets us ship and update things more quickly, and it lets us keep things really kind of fast and minimal and atomic. So Nitro is made up of 3 kind of component parts, and we'll break all of those down individually. But the first one is Nitro cards. So those are things like VPC networking, Amazon Elastic Block Store, so EBS, instance storage, and the system controller. Second is a Nitro security chip. So that's integrated directly into the motherboard. It protects hardware resources and provides a hardware root of trust. Finally, we have the Nitro hypervisor. So it's intentionally very lightweight. You get memory and CPU allocation, and you also get bare metal-like performance. So breaking down some of these key aspects of Nitro. So in Nitro, our software device models that were used in things like Zen are replaced by software-defined hardware devices. So we've broken those pieces out from the DOM0, and we've turned them into dedicated software-defined pieces of hardware. And we'll go into more detail on that in just a little bit. So what that means is that on the EC2 side, those system changes are modeled as hardware events. So things like NVMe or ENA hot plugs or ACPI power state changes, those are all modeled as hardware events. And this is an extension of that microservices model into hardware. So I think we've all maybe gone to a talk at some point where folks talked about monolith to microservices. So breaking apart their big software monoliths into component microservices. And we took that same approach with Nitro. So things like ENA or NVMe protocols are hardened APIs behind which we can innovate, and it gets us things like data hiding and service composition. So that lets us move much more quickly, right? Because we're updating small individual pieces rather than a whole big unit. Our software elements are also all microservices, so they're all dynamically updatable. That means I can update, just one piece, and it means that I have no virtual machine downtime for even the largest updates. So digging a little deeper into some of these components. So for the Nitro cards, we'll walk through some of the cards. So the first one, Nitro card for VPC, so virtual private cloud. ENA controller, and a VPC data plane. So that gets you things like encapsulation, security groups, limiters, routing. Next, we have the Nitro card for Amazon EBS. This is an NVMe controller, and it handles things for the Amazon EBS data plane. So support for encryption, NVMe to remote storage, things like that. Next up is a Nitro card for instance storage, also an NVMe controller. And this is the instance storage data plane. So things like transparent encryption, limiters, drive monitoring. Next, we have the Nitro card controller. So this is a passive API endpoint. The passive is important, and we'll talk about that in a few minutes too. The controller is responsible for coordinating all of the other Nitro cards. So EBS, VPC, instance storage, the Nitro hypervisor, and the Nitro security chip. And the controller hardware is root of trust, so it provides measurement and attestation. Finally is a Nitro security chip, and we'll go into that one specifically in just a second. Now's probably a good time to mention that although we've given a version of this talk before the last couple of years, we always have a Nitro deep dive, but every year it's a little bit different. This year, since I'm a security engineer and we haven't done it before, we're digging into the security side of Nitro. So this talk will be a little bit more security focused than we've been on Nitro talks in the past. So looking at that Nitro security chip, it's a custom microcontroller. It traps all I/O to non-volatile storage. It's controllable only from the Nitro controller. So it can hold system boot. There's various modes for measurement, validating, updating firmware, etc. That's a security measure, right? That we can hold our system boot until we can measure and validate and apply firmware updates if we need to. The security chip is also responsible for monitoring all the hardware interfaces and provides a simple hardware-based root of trust. So digging into the hardware root of trust a little bit, so we mentioned all write access to non-volatile storage is blocked at the hardware level, and simplification of this process has come from offloading to cards, plus you don't have any legacy. So you can see in this diagram that the instance cannot write to the security chip. Only the controller can control the security chip, and then we handle things like hardware, so the BIOS or the BMC, etc. Walking through what this workflow looks like. So the controller is the root of trust. We start there. The controller boots from a private SSD. So the drive, it conducts various integrity checks on different components. If those are okay, it continues with the mainboard boot. And then we apply software updates for all components. So those are all via secure channels. We'll talk about that in a second, and all via signed binaries. So zooming in on one step of that process, let's take a deeper look at the mainboard boot step. So the mainboard can't update firmware, right? And that's another security check. So what we do is we hold that mainboard in reset mode while power up happens. And while that power up is happening, we're validating the firmware with the controller. If it's validated, we continue. And then if that's okay, we either inject the known good hypervisor or we boot a customer AMI from an EBS volume. So how did we get here? So how did we get to Nitro with all of these kind of software-defined hardware devices? Why did we end up moving away from kind of traditional virtualization? So a quick background on some of these concepts. So we started with Xen in 2006. And Xen enabled running multiple operating systems on the same hardware, which is huge. And with Xen, we had two different types of virtualization. We had PV, which is para-virtualization, and we had HVM, which is hardware-assisted virtualization. And with PV, you run on guests with a modified OS. So this can work even on instances where there's no explicit virtualization support. So PV lets you do that in the modified OS. With HVM, the guests are fully virtualized. So there's no modified OS. And your guests get really fast access to that underlying host hardware. With Nitro, we switched to KVM, so totally different system. Nitro provides those cards and controllers, so we talked about those already, but VPC, EBS, instance storage, security, and the controller handles things like CPU and memory allocation, so resource allocation. So the DOM0, so the software device models that were a part of Xen, in Nitro are replaced by software-defined hardware devices on the system bus. And we talked about a couple minutes ago, but that offloading all of these features to software-defined hardware devices is what let us simplify and what lets us move much more quickly with Nitro. So that's what lets us ship so many new instance types with Nitro as we could before. So what this looks like, the DOM0 replacement, you have the Nitro controller, which talks to the Nitro computers, so VPC, EBS, basically the cards. Then you have a hot plug through PCIe, which is then emulated by NVMe on the device. So only that Nitro controller has access to the AWS network. The mainboard does not. And that hypervisor only executes on behalf of the instance itself. So looking into this with graphics, I clearly made this myself, which is why it's so colorful. Step one, we start with the controller. So the Nitro controller, it talks to the Nitro computers, had the same names as those cards, right? So Amazon EBS, Amazon VPC, instance storage, or the security chip. Those go through the PCIe bus. It's a hot plug, and then they're emulated by NVMe on the instance itself. So you can see that they appear on the guest, the instance, just like they did as the computers. Looking at that a little bit of a zoomed out version, you can see where the hypervisor fits in. But this is kind of a bird's eye view, or a simplified bird's eye view of what the Nitro system looks like. So the controller, those chips, those cards, the Nitro hypervisor, the PCIe bus, and then the EC2 instances, so the guests. So since this is a security-focused talk, let's talk a little bit about some of the specific security benefits of Nitro. So first, trust and simplify. This is kind of a first principle that we talk about a lot here at AWS. So one of those principles is secure boot. Everything is through encrypted communication channels. More on that in a second. Hardware root of trust. So we can cryptographically measure and validate the system continuously, which gets us a higher level of trust than in traditional systems. And finally, we have a simplified overall stack, which we got right through offloading to those cards to minimize our trusted computing base. So the second is limited operator access. So with a traditional hypervisor, administrators have unrestricted access. So you can kind of do anything you want. With Nitro, admins only have access through the limited operator API. We've intentionally limited that. Operators have no access to customer data, can't change the system in any unapproved ways. There's no root or super user access. There's no SSH. All access is via auth0 or authn, and logging is enabled. So there's an audit trail for everything that operators do on the system. Next, Nitro is all purpose-built hardware, which helps us limit our attack surface. So with traditional virtualization, you use general purpose servers. So those include unnecessary components. And unnecessary components in this case are kind of anything that you don't need, anything that's not directly necessary for running the hypervisor. Nitro uses purpose-built hardware, so you have only what's necessary, which helps us reduce our attack surface. This smaller attack surface means less area for potential security vulnerabilities. Plus, when we offload those functions to dedicated hardware and software, so like the chips, the hypervisor itself stays really minimal. You might remember this diagram from a few minutes ago. So, right, this is the Nitro controller talking to the different Nitro cards, so EBS, instance storage, VPC, security, hot plug through the PCIe bus, and then emulated by NVMe on the guest. All of these channels between the Nitro controller and the Nitro cards, Nitro chips, which we called the Nitro computers a little bit earlier, those are all private. So we only communicate between the controller and the cards with private channels. Next, we'll talk a little bit about encryption. So hardware acceleration with Nitro allows for a line rate AES 256 encryption of Amazon EBS, instance storage, and network without taking a performance hit. So for instance storage, all data is encrypted. And for Amazon EBS, encryption is enforceable at the account level. And with networking, starting with N instance types, all direct inner N customer traffic, so between N instances, same VPC and cross VPC peering, cross region, all at up to 100 gigs a second. I have to mention my encrypt ham, by the way. When they gave us the stock icons this year to make reInvent decks, they included this ham. I don't know what it's originally for, but I had to include it. I couldn't resist. So next, we have key management. So with Amazon EBS, the volumes have independent lifetimes and snapshots. So that key management is through AWS Key Management Service, so AWS KMS. With instance storage, that's locally generated. So it's used and deleted and generated along with the instance lifecycle. So when you start the instance, you get your local instance storage. When you terminate it, that storage is deleted. With Amazon VPC, The seed materials are generated and managed by AWS KMS. So in all of these contexts, plain text data keys are cached and used only on Nitro computers and are protected and separate from customer workloads. So next is passive communication. So this is a specific security choice. So with Nitro, the hypervisor only takes instructions from the Nitro controller. It doesn't reach out to anything for instructions. It sits and waits for the controller to tell it what to do. All instructions go through private channels. The hypervisor never initiates communication with that controller, and the hypervisor never connects to the network. So the Nitro controller takes instructions from the external control plane. So it listens on our substrate network for encrypted, authenticated API calls, and it also never initiates outbound connections. And you'll see that this is a really conscious security choice, right? Because now, knowing that, we know that outbound connections from either the hypervisor or the controller would be considered a compromise, right? Neither of those layers should ever make outbound calls. So new this year, actually in the last couple of months, something called Nitro Enclaves. So Nitro Enclaves are isolated compute environments that you can spin up as part of an EC2 instance. Enclaves have no persistent storage. There's no interactive access. There's no external networking. All communication is through a secure local channel, so VSOC. The way that this is often described, which I think is really nice, is that it's basically like a tether connecting the enclave to the instance. And they're not connected except through that tether, and that tether is that secure local channel, so VSOC. So root or admin or super users on the instance, they don't have special privileges to access that enclave. Enclaves are good for confidential workloads, personal identifiable information, etc. Out-of-the-box integration with KMS and cryptographic attestation. The Enclaves project is on GitHub, so you can play around with it yourself. There's a whole breakout session on Enclaves this year by one of our EC2 senior principal engineers, Colin McCarthig. So if you're interested in learning more about Enclaves, check that session out. That's it for me. Thank you very much. You can reach me at abbyfull@amazon.com or on Twitter. Thanks for joining us this year. And as always, even though we're not together in person, these session surveys are really important to us. They help us figure out what you guys want to hear more about when we're putting these agendas together for talks. So complete the session survey. Let us know how we did. Thank you, and have a good one.